Welcome back to my series on Mastering GenAI with MLflow. This is the last and the final episode in our 10-episode series, and today we're going to cover multi-agent supervisor pattern. So the idea behind multi-agent supervisor is very important and a common practice that has actually been used in large agentic workflows where you actually have the ability for a supervisor to route or fan out queries depending on what the query is to the appropriate agent. And in today, we're trying to simulate what the Databricks Agent Bricks actually allows us to do that with the supervisor agent. So now we're going to simulate that by using LangGraph and a use case using the Federal Emergency Management Agency data. So we're going to have a user query, for example, as the graph here actually suggests, which is going to be passed to a supervisor router. And the supervisor router is going to classify that based on the content of the particular query or the language used in the query, and classify or determine what particular agent it should route the query to. So it can either route it to a Genie-like agent, which is going to query a structured data queries using the SQLite text to an SQL query, and the database is actually using Pandas data frames, so it's going to be using the SQL engine to query that particular data. If, on the other hand, the supervisor, when it actually receives the classification to be a type of question that needs to be asked by a knowledge-based data, is going to go ahead and execute a query from the document retriever and policy QA. And then finally, the result is going to be synthesized and returned back to the query. And this is a very common pattern in multi-agent workflow where you have an entry point, which is like a supervisor router. It classifies and routes the particular queries based on the agent that you can actually answer the question. And then finally, depending on what the agents are used, in some cases, if both agents or multiple agents are used, the collective answer is returned back to the user. So that's going to be our kind of the simulation, how we are actually do that. And then finally, we're going to use some built-in scorers and some routing accuracy to find out whether the supervisor did the right thing. And the built-in scores will tell us whether the accuracy, the relevance, and some of the guidelines that we actually see. So what are you going to learn today? How to use supervisor pay agent in MLflow, how to actually evaluate that, and how you can actually implement that. The use case we're going to use is, as I said earlier, it's going to be a Federal Emergency Management Agency data. We have about 2,000 entries, and we can ask questions like, how many disasters did actually hit in California? And this is going to be something that will go to the database to answer the question. If we have a question such as, what are the evaluation protocols? Then the supervisor will evaluate or classify that as this is something that needs to be routed to another agent that will query the knowledge base to return the answer to that. Or supervisor might actually invoke both the query or both the agents if the agent needs to query both of them and synthesize the agent. So that's what we're going to do now. I run this particular run notebook for the sake of brevity because it's going to take a long time. There's going to be a lot of code we're actually going through. So over here, I just set up my environment and run my initial setup that creates entries and experiments and all that. What models we're going to use for the evaluation, and what models we're going to use for the classification, and what models we're actually going to use, say, for embedding as well. Because since the knowledge base is going to be using some unstructured data such as PDFs, it need to actually create a knowledge base using embedding. So we'll actually go through that. So this is where our first sort of cell is executed, setting up our environment. And then this is a supervisor pattern. And as I said earlier, the supervisor pattern has two components and two agents to it. One agent is going to be querying the structured data, and the other one agent will be querying a knowledge base, which is made of text file, PDFs, and all of them are going to be in memory for the sake of illustration. In production, you might use a vector database. For example, if you're using this on the Databricks, you'll have a vector database. So you can use vector search, so you can actually have good algorithm efficiency. You might be using delta tables to store all your SQL-related queries. So this is just an example to show you how you can actually use this particular pattern using MLflow and using open source technology that we have. We're going to implement this using StateGraph. Now, StateGraph is one of the components in LangGraph that allows you to create a graph so that a cyclic graph, like a state machine, that now you can actually execute the nodes as the functions associated with, and the edges as the data flow or the state that's going to go from one node to the other one is state management. So the first thing we're going to do is we're going to build this particular knowledge base. We're going to build this Genie-like data structure called structured layer. And structured layer is going to be an SQL database that we're going to implement with about 200 fabricated records from the FEMA. So this is going to create a particular SQL database. And if you actually look at this particular data, you have about 6 or 7 columns, and then each row actually has a disaster ID, the year it got executed, the state, what was the severity of that. So you can actually make queries and inquiring about the state, what happened, how much federal aid was allocated, the declaration date, and so on and so forth. This is a good way to sort of query all the disaster data happened throughout the United States. If you're going to actually have a Genie-like agent that's going to query the database, we actually have to have some sort of functions that the agent can actually use, and those are normally tools. And as we saw in our previous episodes, how you actually create a granular traces by taking a particular function and then decorating that with the particular trace that you want. Now, this is going to be a span type tool because we're actually using the tool type to actually query that. So this is going to be any query that the supervisor deemed that it should be given to a Genie-like agent. This is going to be the function. This is going to be the tool that will actually execute that. So we actually create our usual SQL prompt. And the prompt is very simple. You are an SQL translator. You're going to given a particular natural language, translate that into an SQL, and then go ahead and execute that. So this is what the execute data query is going to look like. We actually have a prompt associated with that. We're going to create a simple lang chain to execute that, and we're going to invoke the chain with that particular thing. Once we get the result back, we're going to pass the particular SQL query and then return that results back to whoever invoked that. So if you actually look at an example of what this particular query might look like, here is a very natural way of expressing how many disasters hit the California. And what this particular executed query is going to do is going to take that particular natural language, convert it into SQL, invoke it on our database, and then return back the results. So as you can see over here, we actually got the language translated into an SQL query, which was executed. And then this is the sequence we actually saw in our graph. That's what it looks like in LLM. This was the chain where we actually did the tool of execute. It ran a relevant sequence. It used the chain prompt. It invoked OpenAI to translate the query into an SQL. We parsed the output and we get the result back. So this is just a test for you to how the agent actually works. The second thing we're actually going to do now is build the knowledge database. The knowledge database is where all the FEMA policies, such as what are the protocols, what are the way of evacuation procedures, what you should do, what you shouldn't do, can be somehow encapsulated as embeddings and put it into a document store where a knowledge-like assistant agent is going to be able to query that given a natural language query. So this is something like very similar to what we actually did in the previous tutorial 1.9, where we actually had a RAG where we actually embedded those things, we put it in knowledge database, and then we actually use cosine similarity to get the most recent, most matching documents based on the query that we actually have. So here we actually have about 12 documents or so, about 10. And we're going to iterate through all the documents that we actually have, and we're going to go ahead and create an embedding. Now, this is, again, another function that the tool is going to be used, the agent is going to use to embed that. As we saw in our previous tutorial, how you can actually decorate this particular query with the type embedding. And all it does, it actually takes the embedding, creates the hashtag for it. We get the current SQL span. We create a cache. If it's already in the cache, then we're going to get it. We're going to set some attributes over here. And this is where it actually calls the OpenAI to create an embedding. And this is going to be a float of numbers that we actually saw in the previous tutorial. We'll get the embedding out of it. We'll take the embedding cache key, which was generated above, and we're going to create that particular cache. And this is just that we don't recreate the same embedding for the document. We're going to use cosine similarity, which we used in our 1.9 tutorial where we did the RAG, where that's going to return you how close are the query compared to the documents that we have, and return the top 3 or the top 5 documents that match the particular query. And then this is just pre-computing embeddings. We're actually creating in-memory cache for this. So here are all the embedded documents. We went through about 10 of these. As you can see, this particular MLflow graph actually shows you the embedded text, all the attributes they actually have. So it's very easy for you to go ahead and use this to create your embeddings. The next thing we're going to do in this particular thing is now we're going to have the ability to define some functions that are going to retrieve documents from our document store. So over here, as we saw in our previous tutorial, this is going to be a search tool called search policy that the tool is going to use, or the agent is going to use. And we're going to decorate that with the type retriever, because it's a span type of type retriever. So this retrieves the document. The second thing is answer the documents. And this is going to be the tool that's going to be used by the agent. So these are the two tools that are going to be used. And since they're going to be span of the operation, we can decorate that with the span. This is going to actually invoke the search policy, which is going to take your query and return you the top 3 documents that has the most closest cosine similarity, and then return that. And then now answer the prompt is where we synthesize the result return. And we're going to get all the documents over here and then create that as part of the chain. So we can invoke that. So you can actually see that this is where, if you actually had posed a question, this is the entire set of tools that are going to be executed. So let's see what happens when you do that. Right over here, we're going to test this particular document to see how this is actually executed. What are the FEMA's evacuation procedures, right? That's what we actually want to test and see how what is actually returned. We're actually invoking this particular function, which is going to be a span operation. What are the FEMA's evacuation protocols for wildlife zone? This is going to go ahead and create that. And this is the thing that's actually fetched from the document store and returned that. So this is what this thing actually looks like. The next thing we actually want to do is to build our supervisor graph. And the supervisor graph is what the routing agent is going to follow. It's going to look like, this is what the StateGraph in the LangGraph looks like. It will have a cyclic graph, which have 3 nodes in it. You will have an entry point where the route now actually classifies whether this is going to be an agent doing the reasoning to figure out where to actually route it. It's going to send it to the execute agents with saying it should be either a Genie or an SQL-like query, or it's going to be a knowledge base. And then based on that, the result returned by this execute agent is going to be synthesized. So it's sort of a linear graph. And each graph will have nodes associated with that, and nodes have functions that are going to be executed at the node, and the edges are the execution flow that the StateGraph is going to communicate that. So each state is communicated through the edge to the next node. So let's go ahead and define this particular node function that we actually have. We're going to define that as a supervisor state that can have any of these particular state. We have a query, we have a route that's going to determine which route is actually take, whether it's the Genie-like, knowledge assistant, or it's going to be routed to both. What was the reasoning? Why did it actually choose that particular route? And then we'll give it the response. If it's a Genie response, or if it's a query that returned from the database, it's going to have that response over there. If it's a knowledge base, then it's going to be all the documents that actually return and synthesize there, and the final response, which is the synthesized answer. So this is our supervisor state that we're actually maintaining as we traverse through our graph. And you can see the previous query that we said, what are the disasters that actually happened in California? You can see that it actually went through this particular chain of spans, answered the document, invoked the search policy because we're asking a particular query. It took the query and embedded the text. It went through the chat prompt. It asked Chat API to give me the query, and then finally execute that particular result. Let's go ahead and let's go ahead and implement each of these particular functions that we have as part of the state of the StateGraph. So we're going to go ahead and do this over here. The first function is going to be to route the query. Take a supervisor state, and this is going to classify. This is going to invoke our OpenAI mini model to find out, given this particular language, tell me whether this should be handled by a Genie-like agent, or it should be a knowledge assistant, or it can be actually both. So this is the classification. This is the route function. This is our prompt. And this is going to be an LLM call, so it invokes the particular call. And then when the routing is returned, it will return one of the three words. Either it's a route to a Genie, or a route to a knowledge assistant, or both. So this is sort of the classification we actually have in this particular graph. This is what we're actually implementing. The next thing we're going to do is implement this particular state function of the node. So let's go ahead and do that. Second function is the dispatcher, which is saying, okay, now we already got the query, what agent should I actually use? And based on this, based on the response returned by the first node, it's going to execute any one of these. If it's the data query, then it's going to execute this particular data query. If it's a knowledge assistant agent, then it's going to execute this answer from the documents by the particular agent, and then respond the updates. And the final function is in the node is a synthesizer. And the synthesizer actually takes responses from either one or both and composes this into a nice, cohesive, rational document put together by the LLM, and then returns the response. So this is what particular node 3 looks like. So what we've done over here is we've sort of defined the node functions, and now we have to define a graph, right? We have to build a graph so we can actually compile it, and then the agents can actually use that. So we're going to build this particular graph using the LangGraph composer called StateGraph, and StateGraph takes the supervisor state and it's going to return you a builder. And once we actually have a builder, we now start adding all the nodes that we actually have. So this part of the code sort of builds all the nodes. This is where it actually adds the routing query, or how the information flows in the state that has changed. And then if you look at what the display looks like, this is the start of the query, this is the routing the query, executes the agent, and finally synthesize that. So let's see if we can actually run this particular query over here, right? We have about 6 of these queries. And see how it actually performs. So the first set of query is that how many disasters hit California in 2024? This is clearly an SQLite query. So it's going to go ahead and route to the Genie-like agent. The second one is what was the total federal aid for the hurricane? This is probably going to be an SQL query, and it'll query the SQLite database. What are the FEMA evacuation protocols for the fire life zone? Again, this seems like a knowledge base, so it's going to route it to the knowledge agent to query, to extract the data. And then finally, this one over here seems like it will actually have to need to invoke both of them. How many flood disasters occurred in 2024? And then what are the FEMA flood response procedures? So this will route it to both and then synthesize that. So let's see how it actually did, right? So we ran about all these queries through this particular supervisor, where we actually invoked the query, and the supervisor was built earlier. We get the actual trace, and we put some information out there, and then we append all this, and then we just print out. This is all just printing out particular data returned from the result. And now if we look at the first query, how many disasters hit California in 2024? Classified as Genie, and it gave a response saying this seems like California's FEMA record, so we're going to give a structured analysis data, and we're going to send it to Genie for that. And the short answer was, according to this specialist, data must be pulled from that particular table, right? And this was the query that translated from the English language to an SQLite. And then this is what the count was returned, and this was the trace ID associated with that. Similarly, if you look at the second query, same result, gives the rationale. This is going to be a database query, and then this is what the query actually looks like. And then so on and so forth. Here's the interesting bit. The last one was how many blood disasters actually happened in 2024 for the FEMA disaster. This classified as both, because it needs to have the information from the database of all the disasters happened in 2024 and what are the procedures for the response procedure. And as you can see, if I go through each of these queries, you can actually see the entire graph. So I actually went back, if I look at my traces over here, and I look at some of the query, what was the total federal aid. You can actually see the entire chain of all the query. The LangGraph executed the route query, which was our first node. It classified the agent and sent it to the execute data query to the database to create that particular query. And then finally, we actually have a synthesizer. You can actually see the entire chain of all the spans that were actually executed in just one particular query. And then we'll go to the evaluation in a minute. When we look into the UI, we begin to see the entire trace of each and every span that was invoked. If we look at something else over here, let's look at knowledge base assistant. If I look at that particular query, you can see that the LangGraph top chain is the route query, which is our first node. And then the second span that was execute agent, which is second node. It determined that this is going to be from a knowledge base. So it's going to invoke answer from the documents. It will do a search policy. It will embed the text. It will get all the embeddings back. And then it will finally send all that to synthesize, which will actually take all the documents together. And you can actually see the entire graph here for purposes of visualization. We can actually look at all the graph to see how many nodes were executed. You can actually see the entire graph being shown, how the node was executed. So we got execute agents that actually called this particular function, which actually had all this particular span. We have a route query that actually called the runnable sequence that execute all of this particular span. And then finally, we had the synthesize that called that. So this sort of gives you a really good view into how your supervisor pattern is actually being used using the traces. What was the general summary of all the 5 queries that we did? So we did the 5 queries, and we said the first query was data. We saw that. The second query was again data. The third query was knowledge base. So we tagged that as docs. And the fourth one was docs again. And the fifth one was both. It actually did Genie were 2, knowledge base were 2, and the both were 1. So this was kind of the whole idea behind having a supervisor routing mechanism that classifies what the query looks like, and based on that, it's going to fan out to the appropriate agents, and the agents are going to execute the results. They might execute independently, or they might execute both of them and then give you the synthesized result from both of them. So then you can actually look at the final result presented to the user. So that was kind of, in a nutshell, how you actually use this particular pattern using LangGraph to execute your StateGraph. This is your StateGraph that was implemented. And then this is the pattern that was actually used to simulate a supervisor pattern. So we had a user query. The supervisor was executed as a LangGraph builder. It actually had 2 nodes. Each of them had functions associated with that. The agent actually used those tools to query the structured database, and the knowledge base assistant used the documented embeddings to get using semantic search, where the FEMA policy is actually stored. Now, how do you know this thing worked? We actually went through a lot of code. So how do you know the query given to us was actually evaluated and made sure they actually went to the right place? Where did we actually mess up? And when we actually find out, as we saw in this entire series, is that the evaluation is a way that actually determines, did the agent behave in the way it was supposed to behave? And if we were supposed to behave in a way, how can we ascertain that it did? So let's go find out how we can actually do that in the last stage of this particular very long tutorial that says, how do we actually evaluate that? So we're going to use 2 evaluation strategy. One is called the built-in scorers, and MLflow, as we have seen in this particular series, has about 60 plus different built-in scorers. So we're going to use over here is 3 built-in scorers to see the relevance, to see the safety, whether the data written was safe, and then some of the guidelines, how we actually want the data to be presented. If you are going to be using the relevant, the built-in scorer, you need some sort of evaluation data set that, given a particular query, what is the expected answer? So we're going to create a small evaluation data set that we're going to test against to see whether the agent is actually doing the right thing, whether it's actually going and routing to the right place. What are the expected values? In other words, here's a particular query. Go ahead and classify that. And then this is what I'm expecting. This is my ground truth. My expected route is going to be Genie. We have our query. We have our expected truth, which is our ground truth. So we're going to use about 6 or 7 of this particular query to see how well the supervisor did in this particular scenario. So, and we can have a predict function associated, and all the predict function does, it just invokes that LLM to classify that, and they will return you the appropriate routing mechanism. What was the final response? And the guidelines is something we actually want to somehow make sure that it actually follows a particular protocol. So the responsive data should include specific numbers and statistics. So if you actually have a query, make sure that it goes to the right appropriate place. Responses about policies should reference specific protocol names or procedures, and that's going to be fetched from the knowledge database. And then combined responses should clearly distinguish between the data findings from the policy as well as all the responses respond. And then all the responses should be kind of actionable, avoid any vague generalities and so forth. So in other words, this guidelines is telling it to be truthful to the documents that you have been supplied with. So that actually does that. So now we're going to go ahead and evaluate this particular scorer using our evaluate function. We're going to have the val data set, which is our ground truth. We're going to use a predict function, and then these are the scores we actually can use. And our first evaluation is with these 3 judges to see how it actually did. And if you actually look at that, we have 5 of these queries that we actually evaluated, and based on that, it gave us all the results of that. So let's look at how it actually looks in our traces. So if we go to traces and we say these are our 5 judges, let's look at what the disaster value over here. And this is our entire chain, but let's look at the evaluation. The disaster's quality was good, right? The response to disaster quality was good. It gave us a rationale why it actually felt that way. Relevance to the query, it was good. The response to the query was relevant to that. And then the expected route was knowledge assistant, right? This is what the expected route was, and this is what actually it did that. So this is kind of a way to evaluate it. We can actually look at the next one where we have what is the total federal aid that was actually given. Now, here it actually somehow found that the disaster response wasn't that good because the guidelines did not satisfy, and that's why it actually gave you that particular response. So this is a good way to say, okay, what went wrong? How do I actually correct that? Relevance to the query was good, and safety, there was nothing that was inappropriate. And then my expected route was what it was. Genie was what it actually did in this particular case. So let's go back now. So these are my evaluation results. The second thing I'm going to do now is I want to really make sure that the custom routing accuracy score is really what was expected. In other words, what it's going to do is it's going to look at your ground truth expected data. It will use the routing emitted by the route query to make sure that this was the right way to route the policy. We actually have our own built-in scorer, and the way you can actually define your own built-in scorer is you decorate that particular function with the type scorer, and then you have the input and output, and it's going to go through all the traces for that particular evaluation data set. And over here, we're actually evaluating this particular data set with the value. If we don't get anything back, we're going to evaluate that as 0. If we get the value back, we're going to compare that with the expected output, the ground truth. And if it's 1, then we got the right result. If it's not equal to that expected output, we're going to give a score of 0. And we're going to run it again now with only simple function, same predict function, same evaluation data set. But over here, the scorer we're going to use is routing accuracy, which is our own scorer. And when you ran that, we pretty much got the right result for each and every of the evaluation routing scorer was the right place. In other words, the supervisor, when he got the query, it classified the query and he routed to the right, or he fanned out to the query to the right agent in all the different 5 queries. So what we actually have done in summary, we tried to simulate the Databricks Agent Bricks Supervisor pattern that actually has the ability to create Genie agents, and one of the agents can be an SQL agent that's querying your tables, that's querying your database, that's querying your structured data, and the other one is actually querying your knowledge base, which is unstructured data. You might have PDFs there, you might have HTML files, anything, and then based on that supervisor pattern, based on that, it's going to route that. And we use that using the knowledge graph, StateGraph component to create the routes, to create the particular node, to create the node functions associated with the node. And then the state is what's being passed between the edges. And then we actually went through the evaluation process by using two of the layers. One, we use the built-in scorers, and the other one, we actually use the scorer to actually use our own accuracy to make sure that the routing mechanism actually work. So that was, in a nutshell, a long way to introduce the supervisor pattern. I have two more notebooks associated with something very similar that you can actually do, but we're not going to create a video. I'm going to leave that as an exercise for you. So one of them is using the same pattern using deep agents, and I would advise you to go through the notebook, which actually does pretty much the same thing. You have an editor agent that has a fan of agents that it actually uses to route that, to do context management. And the crew.ai is another supervisor pattern that allows you to do pretty much the same thing. So in other words, all these last two examples are very similar in having a supervisor that is going to route the queries to the appropriate agent depending on how the supervisor or the crew manager in this case classify that. So I urge you to go through those particular notebooks, but first make sure that you understand everything we actually covered in this. So thanks a lot for joining for me for the 10 series. I hope you learned quite a bit from this MLflow series, and all the notes and all the links are in the description, and including some of the resources used in this particular notebook. So I hope you had a good time learning, and I hope this was informative. And please send me any comments that you actually might have. And what is this next you actually want to see with respect to MLflow? I'm more than happy to share or to create content that actually it needs or ensures that you learn something for it. So thank you very much.